All right, this is Math 141, practice test 1. This is question number 11, and we are supposed to sketch a graph for this polynomial. So, there's a couple things I want to look at. One of them is, what happens as x gets really big? And notice, remember when that happens, these take over, these leading terms. So as x gets significantly large, the plus 6 and the minus 3 don't have any influence. They have minor influence, like basically they're like zeros on the rest of the shape. So I have a 2x over x, which is essentially 2. So what's going to happen is as x gets really big, this thing's going to get closer and closer to 2. Its outputs are. So here I have a horizontal asymptote at y equals 2. What else can I look at? Oh yeah, y-intercept. Y-intercept is here. It's when x is 0. When I plug in x for 0, notice I get 6 over negative 3. So that's a negative 2. So there's my y-intercept. There's my horizontal asymptote. What else can I get at? Oh yeah, I can't divide by 0. So if I look at this, when's the denominator 0? I'm basically saying, when does that happen? And if I solve that, add 3 to both sides. When x is 3, this thing is, I can't evaluate it. I can't divide by 0. So this is a vertical asymptote. And then my zeros, I want to know when it crosses the x-axis. That's when this is 0, because it'll be 0 divided by something. So basically I want to know, when's that 0? So subtract 6 from both sides, divide by 2. So there is my x-intercept. So now I have all my pieces. I can start to sketch my graph. Sorry. So what do I know? I know it has an x-intercept of negative 3. I know it has a y-intercept of negative 2. So just going to go through those two. I know that it has a vertical asymptote at x equals 3. X cannot equal 3. So if x cannot equal 3, okay, kind of a little no man's land there. I also know that I have a horizontal asymptote at y equals 2. In other words, as x gets really large, this thing starts to settle down to 2. And knowing where those intercepts are gives me a little bit of my shape. It starts to go like this, starts to hug those asymptotes. And since it's here, I could sketch it on a graphing calculator. I can plug in some values. I know it's going to have an equivalent up here.